Hello, I would like to show about my CNC machine. It is intended for a milling machine, and I still don't have a spindle. I don't have the Z-axis coupling, but I have the X and the Y running. Let me start a file, and then I will go through the components of the machine, and I will be happy to receive any critique to help me on the remaining items. Okay, let's start Linux CNC. Let's start this file. Okay, we have the x-axis, I said, and the y-axis are working, and the z-axis, I'm missing a coupling. You can see there's no coupling. On the y-axis, we have two 40 millimeter bars, as you can see, and we have 150 centimeter ball screw. I have two ball nuts, one from this side, as you can see, and the other one on the other side. And the reason, the runway is very long, and I thought this will help with possible deflection, or the sinusoidal shape of the ball screw when it is too long. Not for backlash, but I don't know, it may help backlash as well. I have four linear bearing blocks, 3D printed. I have 100% infill, so these are very, very huge, very rigid. But later I will change when the machine is running. I will use the machine to have something better, aluminum maybe. This, of course, not proper, the way the bolts sticking out. I will also, right now I just want to make sure that I can mill metal, mild steel, with this machine. If I can do that, then I will change many components in this machine. So this is the y-axis. On the x-axis, I have four 30-meter solid bars, as you can see. I have four of them, and I have 100 centimeter runway or ball screw. Again, I have two ball screw, one from this side and the other from the other side. It's not necessary, but this is what I have. I have 8 linear bearings for the x-axis, because I have 4 solid bars or linear motion guides, which are the solid bars. So I got 4 on this side, 1, 2, 3, 4, and 4 on the other side. So I got 8 linear ball bearings. Oh, the motor is a little warm. Let me shut down the Linux. Okay, we have here. Okay, let's continue. Let's go to the other side of the x-axis, as they are identical. Now these 8 linear bearing blocks, they are carrying this top plate where I can mount the z-axis on it. And we have also side plates to mount the ball nut, one from this side and one from the other side. Now, where I'm got stuck, there are 2 things, or actually 3 things. Now the side frames, this side frame, these side frames need support, reinforcement, some kind of bar between them under the bearing block this way. So something like this, because this is not rigid enough. So this is one issue. The second issue, which is the clamping of the workpiece, because right now all what I have is just a sheet, metal sheet, bolted to the bearing block, and I have no clue how I'm gonna clamp a workpiece to this. Maybe I have enough holes in it, or maybe I should have some kind of square bars running across where I can clamp something. Anyway, so this is the second issue. The third issue is the spindle. So what I will have is the carriage, or the plate where I mount the spindle on the Z-axis. On this, as you can see, this is the Z-axis, and bearing block for the Z-axis, where I mount this plate to. So what I'm thinking is this will be the motor and the spindle be mounted on this plate, and I think maybe something like 25 kilo or maybe even 30 kilo will be too much for a 16 millimeter ball screw. And a calculation show the motor is okay, but I have holes for a 34 NEMA. So, and I have the motor actually, so I can experiment with this. Originally, I was thinking to have the motor on this side. That means two Z-axis, one here and another Z-axis here, where I have the motor, and a belt between the motor and the spindle on this side. But the Z-axis stipper is on the way, and I really hate to have relocated and use a belt driven. The belt will get stretched, or I don't know. I like to get advice on this. So either have the spindle, the motor on one side, and the spindle on the other side, driven by a belt, and the same signal driving the two Z motors. So the motor and the spindle will go up and down together. So this is one way. The other way is to mount the motor and the spindle like AC servo motor. It will be lighter than induction or even a DC motor. We can have this on this side. I'm only looking for milling mild steel using 6 millimeter, or if 8 millimeter is better, not anymore. So I think 2 horsepower is enough. So it shouldn't be too heavy, but I don't know. I have to experiment. So this is the machine, and I will be open for any critique. I will not be offended, or I will not be defensive, and I'll appreciate any help, and thank you very much.